So, hi everyone, and welcome to our still WIP but brand new Viseu office. I'm Elder. I'm engineering manager here at XGeeks, and I'm super thrilled to have so many people here, so many brilliant people here with us. I wanted to give you a bit of context about some personal context also about what is going on here. So coming back from Lisbon to Viseu during the pandemic to live here in my hometown, understanding there is no tech community whatsoever here in Viseu. This made a huge sense of giving back to the city that has given me so much in the past, to help fostering the tech scene here. This first of hopefully many meetups to come is a huge milestone for us. Of course for the company, but for me personally, also another big milestone is this amazing office. I think it's very good to be able to give people the opportunity to work in such an amazing place, but also a place that can receive so many people for us here, the tech community of Viseu and other regions around, to be here. Just a big kudos to our whole team here for being so bold and believing in us during the pandemic, joining us, and now making all of this possible. Without you, this wouldn't happen. I wanted to give you just a brief introduction for XGeeks. I don't want to take time from our star speakers today. So XGeeks is an engineering company, not an engineering provider capacity. So we are an expertise provider. We are specialized in two different verticals, e-commerce and cloud native. The focus here is to give companies and businesses an edge in innovative digital experiences. Going deeper into one of the verticals, e-commerce, we focus on tailor engineering, SaaS and licensed e-commerce. We want to provide and help companies in the decisions of building stuff from scratch, from zero, using some SaaS licensed e-commerce tool that might be a smarter choice for them, for their businesses. Scaling and implementation strategies. Let's just put it as an example. You have trouble with your non-scaling search, or you have a problem with your OMS. So we are here to your order management system. We are here to help you do the better decisions, help you overcome this obstacle. The other vertical, cloud native, we focused on delivery infrastructure, technology modernization. We want to foster the DevOps culture into different businesses. We are also following two new trends, multi-cloud, hybrid cloud. We know that many big companies use more than one cloud for different reasons. Here we want to help build the tools for the developers to be able to handle these environments better. I wanted to talk to you a bit about our culture. Obviously all the dependencies we have with all the other words that are there. I think by now probably you all think that I'm a bit biased to tell you about this, but I really believe we are a group of people that really enjoy working together, spending time together on our social lives. I think it's good if you talk to many of our engineers here and ask their own opinion, but I really believe this. As an organization, our structure, I think it's very flat. We are always trying to improve our company throughout the feedback of our engineers, the people working here. We do this by having monthly retrospectives. We collect this feedback and we iterate over it and try to improve always. From the engineering side, we have a big tech stack. Can go from PHP, Python, Golang, Java, JavaScript, TypeScript, all the respective frameworks. So a lot of different stuff. If you are curious about it, I think you can just go to our GitHub page and check our tech radar. You will find everything there. Regarding clients, we have many different clients, Daimler, Mercedes, DHL, many different projects, in many different countries. We have US, Europe, Middle East, so a lot of different stuff. I like to believe most of them, because there are a lot, we are just working with cutting edge technologies. Yeah. So regarding community, communities, we like to believe community is part of our DNA. Being community driven is part of our DNA, as you can see from this event. And yeah, we also have an academy. It's something we are really proud of. We are trying to form engineers from zero to hero, DevOps engineers from zero to hero. And it's also a really cool topic because you have here some of our mentors, I don't know where they are, but some of them are here, okay, back there. And also some of our mentees. I think it's really a really cool topic to talk about and understand their experiences regarding this. We have also different events in different locations. For example, last year we held the second edition of Geekathon. It's a hackathon in Leiria. We had over 70 engineers there. And yeah, regarding content, written and video content, you can check our YouTube channel or Medium channel and see everything we have posted there. There is a lot of content, yeah, and I think some really cool. Saving the best for last, it's our team, our amazing team. We are now more than 110 engineers. For me, one of the people that were here from the day zero, it's really cool to see how much we scaled and how far we've come. Different engineers, different background, but overall amazing people. I think it's very good for everyone here that is not from X6, and you have a lot of people to talk also to our engineers and understand their experience better. So yeah, this is it. I'll just leave you with our social media links. I've already mentioned some of the YouTube and Medium content, but also our day-to-day life with Twitter and Instagram. I will just add that in terms of offices, we are located in Lisbon, Leiria, Viseu, Stuttgart, Cologne, Munich, Zurich. Yeah, so we have a lot of different XKI Group offices. And now I will pass the word to the other elder, our amazing speaker, a smaller version of me. So yeah, please, elder.
From elder to elder, here we go to the second part of today's talk. First of all, thank you very much for coming. It's amazing to see so many people in our brand new office. Today I'm going to be talking to you about how to break down challenges and architecting solutions, specifically from a full stack point of view. So we will be going through backend, database, frontend, and we will dive a bit deeper into some of these topics. But yeah, it will be the whole journey. First and foremost, who am I? I'm Elder, the second elder of XGeeks. I'm a full stack software engineer. I've been working in the field for the past 11 and a half years. The last 2.5 of which have been with XGeeks. As I said, I'm going to show you my approach when faced with engineering challenges. I guess we've all been there on those types of challenges that you don't really know exactly how you're going to do the entire solution, but you know at least some of the steps to start on it. And that's one of the things that I like to do the most as a software engineer, to discover the path to a full solution for a specific problem. And this will be done today with a practical example, as I've said before. So first, before I talk about the issue that we were set off to resolve, I think it's important to set the stage. So this specific issue happened on a large-scale e-commerce company, a company that had over 400 engineers. At the moment, we are over 500, but at the time of the challenge, it was over 400 engineers, divided on over 40 different engineering teams, some from front-end, back-end, data, you name it. And these teams cared for over 500 GitHub repositories. So this was kind of a huge train, a fast-moving train. And since the entire tech stack of the company was mostly revolving around TypeScript with Next.js for front-end, Node.js for back-end, and some smaller scale React applications in the middle, the design system package was implemented as an NPM package. So all of the components that were used on the customer-facing web pages were consumed from, or at least the most reused ones were consumed from a single package, which was maintained by the design system team. And the specific problem that I'll talk about today happened when I joined this design system team, or this specific challenge. This design system was consumed by over 40 different repositories inside the company, and it was updated on a daily basis. And this was pretty much the norm for all of the teams. All of the teams were operating on a very agile methodology, which meant that it wouldn't be unreasonable to have like 100 different commits moving to production on any given day. So as you can see, a fast-moving train, and with a fast-moving train comes a set of challenges. The challenge that I'm going to talk to you today is, due to this specificality of the company where each page pretty much was maintained by a specific team, you would have one team dedicated to the home page, to maintaining the home page, another team dedicated to the search results page, the products page, the checkout journey, etc. And since each of these pages operated independently from one another, even though they shared the design system, sometimes they didn't share the same version of the design system. And there on the left side of the slide, you can see, for example, the product card as shown on the home page, which is the leftmost mobile phone there. And you can see that the layout is quite different from what you see on the right, which was the same thing, but on a different version as shown on the search results page. So you can see, for example, that the price is, it has a very different highlight on the first image when compared to the second one, and the same goes for the main call to action. One of them is black, and the other one had already shifted to red. The one on the right was red. This kind of issues contributed to a very poor user experience, because the user was used to, if you imagine a user that was browsing the home page and he sees a bunch of product cards, he gets used to seeing the price next to the call to action, and if nothing interests him, then he will search for a product and he will be taken to a different page. And now on this page, he will see quite a different story when it comes to the product card. And this familiarity will be broken, and he will have to learn, again, this specific component. And this is something that piles on. As you can see on the right side of the screen, we have another scale of the issue. In this case, it was the toast component, as shown on the search results page above, versus the product details page below. It's, again, this one was a very smaller issue, but all of these things pile up to a bad user experience in the end. And so, during the first talks that I've had with the engineering manager of the team, we've decided that one of the ways we could approach this without changing the entire engineering structure of the company would be to empower the design system team with a tool that would enable them to track the adoption of the design system package across the company. So in this tool, the design system team would be able to show the consumers of the design system, show which repositories are using this design system as a dependency, show which version they are using, and then comparing that with the current version, we could understand which repositories are falling behind on the version, and we could notify them to update if necessary. So this was sort of the solution that we imagined at first. And then my first question was, what kind of data do we need to know in order to fulfill this solution? So the first thing is, we would need to know what's the current version of the design system. So that's kind of the baseline for the entire thing. This was pretty easy. Since it was an NPM package, it had a package log file, and the package log specified the current version of the package if we looked at the main branch. So we could extract that from there. Easy enough. Second step, who is using the design system? Since all of these repositories were living under the same GitHub organization, we could use the GitHub API to search for repositories which have the design system package as a dependency. And this would give us the consumer repositories. Afterwards, we would need to know what version is each component using. Same thing, by answering the second question, we would know the answer to the third, because on the package log file of each consumer repository, we would have the version of the design system that they are using. And lastly, which components is each consumer repository using? This one was a bit trickier, and to be fully honest, this is one of those things that I didn't really know exactly how I was going to solve, but I had at least an idea that worst comes to worst, I'll just download the consumer repositories, I'll clone them locally, and I'll just run some scripts to fetch data and see which imports are being done from the design system package. So it should be solvable. So we set out to do it, and the next step was, okay, if we'll do this, how can we architect this, this system? As I've said on the previous slide, we were probably going to be using the GitHub API to query for who are the consumers of this design system package. And we would likely have to clone the repositories, the consumer repositories, to do some sort of regex parsing of the files or some sort. So we decided to use some scripts in Node.js to do this, and these scripts would fetch the data that we needed. They would store them on some sort of data storage. For now, this was not really critical for me. It was not critical for this specific project. So we decided to leave the type of data storage a bit more to the end of the project, or to the middle. And then there would be a front-end app that would show this information that we gathered in statistical indicators like tables, charts, etc. So the first piece I wanted to get done was the scripts, because if the project was to break, it would probably be here. It would probably be because we can't really fetch some of this data. So the first thing that the scripts should do is fetch the data pertaining to the design system, so the current version and the components that are available. So the current version, as I said, could be fetched from the package log.json file. You can see it on the left. It was an easy parsing, done. Now, the second step was the components available. These are the components that the design system is exporting. Initially, I thought that it would be as easy as just seeing what's being exported by this package, but due to the files, the way the files were stored on the repository, this was not really that simple. And so we had to kind of work around that issue. And one thing to note is that this package was using Storybook to document all of the components. So this meant that for every component that we were exporting, there would be a matching Storybook file, as you can see here on the right. For example, this is for the accordion component, and we have the accordion.stories.tsx file. And these files, these specific files for each component would always have a default export that would include the component name in it. So what we've done is we can just isolate all the stories.tsx files and then parse them to fetch the component name from what's there on the 12th line. So this worked like a charm. There was no need to change it. So far, it's still working. So this was a pretty crafty solution for this type of issue. I'm sure there's probably another better way to do it, but this was kind of a side project. So it wasn't like the entire team was working on it. It was like a side project that we wanted to get rolling as fast as possible. And sometimes you'll have this. You'll have to find a solution, settle for the solution, and later you can understand what you should improve, because there are many things that you can improve throughout an entire project. And you don't really want to be stuck on something right at the start. So this was a solution for this specific issue. And now we would move on to the second part, which is who are our consumer repositories and what components are they using. To find out our consumer repositories, and since all of the repositories lived on GitHub, we can just use the GitHub API and search inside the organization specifically inside the package JSON files, because these are the files that specify the dependencies of an NPM package, and we would search for the name of the design system. There I have it as design system, but in our specific case, it was something a bit more unique, so there was really no risk of collision with other package names. Then this would fetch us the consumer repositories. It would give us one result per package JSON file that was importing the design system. So this was good. And then the second step would be what components are each of these repositories using. To this, the best solution that I could find so far was to use a package called React Scanner. And what this package does is, given a React application, and since Next.js uses React under the hood, it also works on Next.js. Given an application, in this case React or Next.js, you can just crawl that application and you can specify which imports you want to search for. So for example, as you can see there on the second line of the second screenshot, we would search for imports from the org name / design system, and we would need to specify for each repository what's the root of the repository. And this package would give us an output of all the components that are being imported from that specific package, and also what props they are using, which was kind of cool for something that I will explain later on. So with this, the main logic of the scripts was addressed, and now we only needed to know how we are going to deploy and execute them. So our idea, and since we are using the GitHub API, we are cloning repositories, we don't really want this to run in runtime. So whenever someone wants to see the table where we can see the consumer repositories and their versions, we don't really want to be doing all of this. So the idea was to have these scripts run asynchronously, saving the data on the database, and then the front end could consume the data. So this would be executed once a day. We can easily adjust this in the future. It works like a cron job. The deployment is done with serverless, which makes things easier to maintain, because any developer that has access to that repository will know exactly what are the constraints for executing these scripts and where they are deployed to. And they would be running on AWS Lambda. And here is another point that could be improved in the entire process, which is in this execution on AWS Lambda, every time the scripts were called, and since they were only called once a day, they were always going to do a cold start. So there will be no shared storage between executions, which meant that for each execution that we were going to do, we would have to clone the entire repository tree instead of just fetch and pulling if we had a persistent storage across Lambda executions. So this is another thing that we've used to get going fast, but it's something that we can potentially improve in the future. So instead of using the default ephemeral storage for AWS Lambda, we could use persistent storage like EFS, for example. Now, moving on to the data structure, and personally for me, it's easier to think of these data structures as relational databases because it's what I've personally been working more in the past. So this was the structure that I've imagined at first. So on the left side, we would have one table for the design system data. It included like the current version and other necessary configs for the front end. Then we would have a components table that would have the components that we are currently have available on the design system. And then on the right side, we would have the consumer repositories. Each consumer repository would have their current version of the design system, and then there would be a relationship table to let us know what specific components is this repository using from the design system. And in this relationship table, we would also save the props that each component is using. And this is specifically useful for instances where, for example, you use a new prop, you release a new version of the design system that has new props to a specific component, and you want to see which repositories are using the new props, or which ones are using, for example, potentially outdated props that we don't really want to use anymore because they would change layout or they would change some other thing that is outdated. So this props usage that is given by React Scanner is something that was useful for us later on as well. And it was a very nice to have. Then for the data storage, as you can see, you can start to see a trend. Everything was hosted on AWS. For the specific storage, it was managed with Terraform. And after some talks with principal and platform engineers, we decided to go for DynamoDB as a data storage. So instead of a relational database, we would go with DynamoDB. This is because we tested or we validated different approaches. So in order to use a relational database, we would use something like RDS for Aurora or MySQL or Postgres. But the issue that we had with RDS is that for this type of application that is going to be executed like maybe 1 time a day per scripts and maybe 10 times a day for seeing the dashboards, we don't really need a database to be running all the time. And there was no way to have a database running or not dependent on if the site was accessed or not. We could shut it down during the evening, but if we shut it down, the website, the whole entire system will be off. So that's not something that we wanted. And when comparing, for example, the minimum tier of data of machine that RDS has available versus DynamoDB with around 1,000 accesses a day, DynamoDB is still much cheaper, like 10 times cheaper at least. It would also provide us with faster accesses to data due to the way that we structure the data afterwards. So this was it for the data storage. Then for the front end, again, the same trend. It was deployed or hosted on AWS. It was a Next.js application, and it was also deployed via serverless. And this deployment led to each page being compiled as a single AWS Lambda. So if we had, for example, 3 different pages on the dashboards, each page would be a single AWS Lambda that would run on demand. This is an entire topic that we could delve into, but it's maybe something for a next presentation some other time on the next Tech Talk. So for now, I won't be going too deep in the dashboards because we still have just a tiny more ground to cover. For the repository structure, to ensure quick iteration, we went for a very simple structure. So this would all live in a monorepo. All of these pieces, as you can see, they're not really that huge. But if they grow large enough that they warrant a specific repo for them, it would always be simple to split them apart from this repo. So at the beginning, we had a folder .github which contained the configurations for the CI/CD pipelines because we were using GitHub Actions for those. We would have an app, infra, and scripts folder. So app for the front end, scripts for the back end scripts that fetch data and save them on the database. And then an infra folder that contained the definition of the shared infrastructure. This shared infrastructure for now was only our database, which was defined in Terraform. But later on, if we needed anything else, it could live there. And then the last topic that I'll talk about is CI/CD, how we were deploying this entire system, how we are deploying this entire system. And for this one, we had 2 major concerns, 2 major restrictions. So we only want to deploy things when they are changed. So if we change, for example, a bit of code on the scripts, we don't really want to deploy the application and the infrastructure as well. So only the scripts should be deployed if only the scripts are changed. And then the application and scripts deployment should be dependent on the deployment on the infrastructure first. So this first point, deploying things only when changed, gave us another different challenge, which was, how are we going to do this? GitHub has a default way of doing this, which is using the paths parameter. So as you can see on the left, that's the definition for a workflow that would be triggered whenever we push changes to the main branch, and if those changes contain changes on files inside the scripts folder. This would work, but it would require us to have different workflows for the different folders. So one workflow for the infrastructure deployment, one for app, and one for scripts. And this is not something that we wanted. We wanted to have like a general overview of the deployment in one single piece, and not having to look at 3 different things if we changed the 3 pieces at once. So we investigated this paths filter action, and what this paths filter does is basically the same thing as the GitHub paths parameter, but it allows us to do this on the job or step level. And I'll explain a bit more of this in the next slide. So in the end, this was the desired pipeline. So whenever there are changes pushed to the main branch, we would check which folders have changed. Then we would know if we need to deploy infrastructure or not. If not, the Terraform apply job would run. And then afterwards, the deployment of the apps and scripts was good to go. So this check changes script uses that paths filter action. As you can see down below, we have a step that is going to check for changes in the infra scripts and app folders, and this will output three Boolean variables that will tell us if these folders have changed. We would then export those variables as job outputs, as you can see above, with the same name. So we could then use them like so. I hope this is readable for everyone. It should be, I hope. So if not, I'll try to read it out loud. So for the Terraform apply action, the first thing in the red square, we just specify that this needs the check changes action to execute beforehand. So we don't want to run anything before we check which folders have changed. And then we also specify that this Terraform apply will only run when there are changes to the infra folder. And this was done via accessing the output from the previous job. Then, lastly, we would have the deployment of the app and scripts. Both of these are kind of similar, so I've only specified here the scripts part. This deployment was dependent on the check changes and the Terraform apply. But here, there's a very interesting, or maybe not interesting, we'll decide later, thing, which is, in order to run the deployment of the scripts and app, regardless of whether we had infrastructure changes or not, we would require this always keyword, the first thing that appears after the if. So this was the only way to ensure that the deployment of the scripts would go through, even if the Terraform apply was skipped. So, for example, if you only change one line in the scripts, if you do any change only on the scripts, you would do the check changes. Since you didn't change anything on the infrastructure level, you would skip the Terraform apply, and then you would execute the scripts regardless. But if there were infrastructure changes on the same commit, you would want to first apply the infrastructure changes and then deploy the scripts. This seemed fine for a bit, as a lot of things do, but after a while we noticed that this always brought with it some side effects, some terrible side effects. So if you were to run this pipeline and, for example, at the last minute you wanted to cancel this workflow, so you noticed that something was wrong and you don't really want to deploy anything else after, for example, the check changes, you would stop the workflow manually on GitHub. But these two actions will always run. So even if you stop the workflow manually, this will still be executed, which is terrible. So I've left it here. We have since moved away from this always keyword, but I left it here for educational purposes. So make sure that if you use this keyword in the future, you have protection against manually deploying or, for example, having an action fail beforehand. Because if the Terraform apply fails, this will still run because it always runs. So yeah, be very careful before using that. Or just don't do it at all, as we did afterwards. Now, we are approaching the last slide. So here I just wanted to leave you with some potential improvements to this entire solution. As you've probably noticed, I've always referred to the consuming applications as a consumer repository. And this might not always be the case. So if there is a consuming repository that has two different applications, for example, one for a micro frontend and another one for a website page, then we were not supporting this structure. For us specifically, we don't really require it because there were no other monorepos in the company. But if there were, this structure that we have talked about won't work. So this is something that we can improve in the future. Another thing would be to add a notification system. I think this would be very valuable, and it might be one of the next things that we iterate on. This notification system would allow us, for example, to automatically notify teams on their Slack channel if they have a design system package that is out of date, or a component that is out of date or deprecated, etc. This is probably one of the most useful potential improvements. And the last one was the persistent storage that I've talked about before. So at the moment we are using the ephemeral storage, so we have to clone the entire repository trees, and this is probably not ideal. We could just keep the same storage and just fetch and pull to get the latest version of each repository. So yeah, this is pretty much it. Before we go right on to questions, I just wanted to leave you a side note. So this was just my way of approaching this problem. There's probably 100 different ways, probably 100 different better ways. But I just wanted to leave you with kind of this journey through a full stack approach to solving one kind of problem. So don't take this as a golden pill. Take it with some grain of salt and yeah, investigate with your team what are the best solutions for your specific problems before you commit to anything. And yeah, this is pretty much it for the presentation. Now we have some minutes for questions. If anyone has any, feel free to shoot. Otherwise, I won't be running away after this, so you can also approach me after the talk. So yeah, if there are no questions, then I can pass on the mic to my dear colleague, which is the third elder of the company. No, I'm joking. It's not elder. It's Luis Serra. But yeah, that's it.
Hello, everyone. Thank you so much for being here. It's a pleasure for me to be here speaking for you. I will talk with you, or we'll have like a discussion regarding DevOps and how DevOps process helping this cloud native, whatever that means, transformation world, and why this is so used at the moment or at these days. Sorry. So to start, this will be the agenda for today. I will talk with you about what DevOps is, because I think this is a term that a lot of you already heard, but sometimes is not well defined what DevOps is. What are the main processes? So since they will help the cloud native transformation. What is cloud native transformation? Of course, the journey until the cloud, so how we get here. And let's mount the leg. This is an exercise that I want to make with you. So how you build a cloud native environment, and at the end, of course, that will be a Q&A session, okay? So first of all, who am I? My name is Luis Serra, like Elder said. I'm a DevOps engineer since 2018, something like that. I'm at Teck since 2020. I call myself as a cloud native enthusiast, and because I'm always looking for something around Kubernetes, around the cloud native foundation, or any tool that can appear to help our lives, and I'm always trying to be updated, at least. Okay, that is very important in this field. Okay. So what the hell is DevOps? I know that I told you that I'm a DevOps engineer, and this is something that gives a lot of confusion and talk. Actually, DevOps engineer doesn't exist because DevOps is not a role. It's more like a kind of culture where this all came from. This, I think, is very important. This started in 2019, if I'm not wrong, where some big companies start to identify some silos of information. So development and operation were the main ones, and this was impacting the way they were developing and how much they can deliver to the clients, of course, to the customers and so on. So the time to market was critically impacted because of these silos. Because you have the development team that knows, okay, I know everything from my code, and you have the operations, and actually, if you don't have this kind of not information, but communication between these two teams, you know that it doesn't fit and it will impact your workflow. And why I say that DevOps engineer doesn't exist, and this is truly culture. Because if you create a new role for this kind of problem, you just will move this problem or these silos into a third one, or you will create a third one. And that's why DevOps is not a position. That's why nowadays you see a lot of different positions: platform engineer, cloud engineer, SRE, and so on, because they start to specify in different areas. Okay, but DevOps is this all transformation. I like to call it like that. It's all the transformation that, okay, it tries to reduce the time that it takes to development and deploy software systems. Okay, of course, providing, updating, frequent updates, bug fixes, and so on and so on. So it's always to have an efficient way to deliver products. Okay. So being this said, so what are the main DevOps process? I choose 5 of them. Okay, you can segregate this into different. You can have more granularity to divide this kind of process, but I think this is the 5 more important process. The first one is CI/CD, like Elder said, continuous integration, continuous delivery. That is a process that automates how you integrate code changes between shared repositories, how you deliver, what are the workflows that works for your entire setup. And this is where, actually, this I think is where you start to work on. The continuous integration, continuous delivery is what will get or will give you the ability to deploy it faster, okay? And because it's an automated process that starts earlier, on the earlier stage as soon as possible, for example, on a pull request, merge request, if we are talking about GitLab, sorry, you will have faster feedback, because if you got any error, you can catch that error there. Improve quality, faster time to market, once again. The second process is infrastructure as code. Once again, like Elder said, I didn't see his presentation, but is matching. So infrastructure as code, everything, all your infrastructure must be ready to be so flexible to, if your applications and if your development cycles are now quicker, if your infrastructure doesn't follow these new ways to implement and I want to, on this demand, sorry, is what I want to say. If your infrastructure doesn't follow this demand of your market, it doesn't matter if you are able to deliver, I don't know, how many versions per day. So consistency, scalability, and efficiency. The third one, automation. It's a little overlay with CI/CD, but in this case, we want to explain. So automation, it's not only the CI/CD process, it's other processes like testing, quality, security, and so on. All the things that can be automated, once again, as soon as possible, because I don't want to find a security vulnerability only when my code reaches production. This doesn't make any sense. So the old way back, it will cost you money, and it will impact the vision of your company. It will impact how clients see your company. That is the most important one. As you can see, so it has common characteristics or benefits with CI/CD. Faster feedback, improved quality, and great confidence. Because if you test it properly, you are confident that what you are saying to production is working as expected. Then observability. So if we are talking about systems that are always changing according to demand and so on, and other topics, it's always good to see, because when we talk about cloud native, is always like, okay, my things are running on the cloud, but where is the cloud? Is there? I don't know. So that's why observability is very, very, very important. The things are moving faster. I have to check if everything is working. I know that I have a lot of automation and so on, testing and so on, but it's not 100% correct. There are always risks, so that's why observability is so important in this kind of environments. Visibility, insight, and compliance. Compliance, especially here in Europe, is very important because you have like RGPD, right? And you have to check it if you got any problem on production, for example, and any leak. You have to be aware if anyone is attacking you, and you can only get this kind of information with observability. And finally, communication. So if I start to talk, okay, there is a communication problem between two teams and two information silos. If there are no communication, this doesn't work, guys. So that's why communication is very important. Alignment, efficiency, and innovation. These are the main three keywords that you get or you can achieve with this kind of process. And now, what is cloud native. So very weird to explain sometimes what cloud native is. So it means that you design, build, and operate your applications and infrastructure that are optimized to run on a cloud environment. What this means is basically that you can achieve with your whole system at least these six characteristics, okay? Elasticity, scalability, fault tolerance, high availability, resilient, and responsive. They are all connected. It's two factors that you can follow to make sure that your application at least is cloud native, ready, but I want to achieve something more. This cloud native ready is not is something that I want to prepare, but to achieve what? Usually this kind of benefits. And now, but how we get there, then I think this is important to try to understand how we reach the cloud. Because, okay, now everything is on the cloud, but why? It has to, how we came, how was the path until here. Basically, we start back there with legacy, what we call now legacy systems, okay, that relies especially on proprietary hardware requirements, that you have a lot of problems and with hardware licenses and so on and so on. So, and this was not scalable at all because to manage it was like a nightmare. Then with when virtualization appears, the people start to think, okay, so I think if I virtualize some parts of my scenario, probably I can replicate it a little bit more. And you started to have like virtual machines at that time with hypervisors, and this, as you can see, so you remove, or you don't rely on hardware anymore. Of course, that hardware is there to run something, okay? But you start to move responsibilities in two different topics, in two different parts at least. And you start, one thing that is very important, the automation, that will help you to reach the cloud native environment. Then you have this phase that is cloud ready. Being cloud ready doesn't mean that you have to use the cloud, because sometimes the cloud is not what you want, or is not what you can do for legal, for example, legal requirements is one option. For example, I don't think that a bank has all the registers and all the databases on the cloud. Probably it can have, but it doesn't mean that they are there. So cloud ready is one thing, and cloud native is another thing. But it's in the middle. It has everything that comes from virtualized, okay? But you have automation, now fully automation, not partially automation. And if you check the second point, no reliance on OS level SLA, API centric. Redeploy instead of restore. This is very important. Infrastructure as code and redeploy instead of restore, they are somehow together and can have a little overlay between some parts of it. So you don't configure or change anymore. You take more advantages if you can create a block that can be easily replicatable and replaceable. So you don't have anymore a machine and you start to configure it, and then you have another machine on when your demand increases and you have to configure it, but it won't be exactly the same as the first one, so you will have a configuration drift. So this part is very important. Don't try to use the cloud if your infrastructure is not immutable and ephemeral. Okay, every component from your machines, your containers, and so on, they must be replaceable easily. You don't change it, you just replace it for a new version. And of course, then you have the cloud native. All things are API driven because why? Because like that, with this way you can extract all the responsibilities for the different stakeholders. They can communicate themselves with each other, self-healing, auto-scaling to achieve what I told you before, fault tolerance, on-demand scaling, and so on and so on. And now I want to make with you an exercise. So, okay, I'm saying that, okay, you can extract responsibilities, whatever that means, but do I have to create another systems to work with that responsibilities? And the answer is no. Basically, there are a lot of tools that help you with this transformation on nowadays, okay? And this is just an example, and there are, I don't know, maybe 1 million different paths. This is just one way to do it. And I just want to give you an example how you build this, or how you start with a project and you start to put especially tools that will help you. And this is what DevOps usually do with DevOps, cloud engineering, platform engineering, and so on and so on. So you can divide this into multiple persons, okay? And this, for me, these are the layers that you put one on top of each other, and you'll start to build a cloud-native environment to hold your applications, backends, frontends, and so on. Usually, you start with this, GitHub, right? Of course, with a version control system. Let's say that we start with GitHub, for example. One of the first process that I talk about, CI/CD. So let's automate the continuous integration and continuous delivery part. For example, your team will discuss and say, okay, I have a GitHub, makes sense to use GitHub Actions, for example, that is a CI/CD tool from GitHub. And then you say, okay, but since I have now an automated process, probably I can start to implement some automation or quality on it. And you will set up, for example, a Sonar Cube to do it, to check for bug smells, vulnerabilities, and so on. And then you say, okay, I have now, my applications are being checked in terms of quality. I have automated process, so I want to build a package that can be easily replaceable with my own application. Probably you will containerize it using, for example, Docker. And now you heard some buzzword that is Kubernetes, and you say, okay, I want to go there because everyone is using Kubernetes. And Kubernetes is a container orchestrator, so you already have your applications. You already have your applications containerized. So you start to implement it Kubernetes. And this is a very iterative process, as you can see. So it depends. You can start a project and it's like that, or you can start much later, or you can start in back there where there are nothing. Okay, this depends on the size, on the maturity of your project. So I know that at the end it will be a lot of different tools. So you start, okay, Kubernetes is fine, but man, the files are too static and I have 3 or 4 different environments. It's kind of mess to have a different file with the definitions for all the environments. And you start, okay, I need a package manager. For example, Elm. There are a lot more, okay? And then you start, okay, this is good, but the demand of my company is starting to increase. I don't have resources enough to do this. I have to move to the cloud. And this is, at this point is where you get that question. So which cloud? How we will deploy all the things in the cloud? By hand? One of the process of DevOps is infrastructure as code. When you choose a cloud provider, it depends on a lot of things. So costs, regions, availabilities, but mainly I think it will be with costs. But let's say that, okay, I want to go to AWS, but will you deploy it all things by hand? I don't think so. So infrastructure as code, again, let's automatize and make it replicable. Okay, let's say that you will use CloudFormation, that is a product specific, AWS specific, to deploy at AWS. And then you will, and this, once again, very iterative. Okay, my Kubernetes is working fine, but then, man, I only want one load balancer pointing to my Kubernetes, so everything goes there, and then inside of it, I want to split, and not to split, but redirect the different traffic for the different components. Okay, let's say that we will use Nginx. Man, I have another problem. I have some credentials, API credentials. I'm using an external service, and I have some sensitive values that I want to store somehow, and my applications need. Okay, I won't put that on. I won't put that on a Elm or a Kubernetes file. Okay, let's, for example, use a secret manager to store this kind of information. Okay, everything is working now, but I don't know if it's working as it should. I don't know if my Kubernetes are healthy. I don't know if the resources are enough. I need some observability on top of it. Prometheus to get some metrics. Okay, metrics are fine, but I want to see what's happening inside my applications, and I'm getting some errors that I don't know what they are. And it's kind of mess to have everyone messing up with my Kubernetes cluster, checking the logs of the pods. Okay, FluentBit, for example, to extract and forward the logs to outside. But where? Elasticsearch, for example. This is one of the major and most known time series database that usually are used to receive logs. Okay, I have everything. They are on a database, but my users can see it. Kibana, for example, is just a dashboard for it. Let's say that I started with GitHub, right? But let's say that you have GitLab, for example. You have a good promotion on GitLab in the next 3 months, and okay, I want to change it. Does it make sense to use GitHub Actions anymore? Probably don't. You can use it, but it's a CI/CD tool that comes from GitHub. You can replace it for Drone CI, for example. Okay, and now your company is increasing, and you start to reach new regions, and you get a problem. Okay, my cloud provider, AWS, doesn't have any data center on that region. Very strange, but the time that we have to respond to our consumers is very, very critical. So I have to, and I already saw, and only Azure have their data centers on that region. No problem. Let's replace it. Okay, but we were using the CloudFormation to deploy this kind of infrastructure. Let's replace it. Terraform, for example, a very well-known player. Okay, but my secrets were on a secret manager that is a service from AWS. Once again, guys, this is all integrations. Let's replace it. Oh, but FluentD, I have Elasticsearch and Kibana, so they are all a stack. I'm missing Logstash. Logstash can easily replace. But you know, my team is not big enough to deal with observability because it takes quite time to have a proper observability setup, and I don't have, for example, a site reliability engineer. Guys, let's just move on and let's use a platform, Datadog, for example, platform as a service. Okay, I'm very happy, but I'm starting to. There are a lot of things to deploy it and build because these applications must be deployed. Okay. Somehow into your Kubernetes cluster. Okay, but I don't want to create a pipeline every time that I have a new support. I will call it support. For example, Prometheus, Datadog, and so on. Support tool. Okay, GitOps approach, for example, to do it. Flux. You don't like Flux? There are already with Argo CD knowledge in your company. use it. Okay, my system is working pretty fine, but now I want to be sure that it's resilient, and I want to mess it at all. Cows mesh, and Cloudflare, and at the end, somehow in the future, you will reach something like this. It doesn't make that you have to use all of these things. Once again, it's a very iterative process. It depends on your project size, your project requirements, your project maturity. It depends, guys. But as a DevOps, I think that we have this kind of role to check what are requirements of our project, and especially help the teams to decide and facilitate this kind of information between development and operations. And I will assume that it's not me or you, okay? You are just a simple DevOps, but this is the kind of things that I show that is very important. This eye overview about all the things, and very, very important, communicate and show the teams and explain them for your developers. Okay, man, I want you to, or I need that you deliver your product like that, because if you don't, it will impact operations on that thing, and the other way around, okay? And now you ask, okay, but how do you know so many applications and so on? I don't know, sorry. They know, okay? Cloud native computing foundation, exactly. They have conference, community, training, certifications, and a very useful page that I will try to. Sorry. It's not there now. Guys, it's here. Sorry, I have to. So here is like the Bible of DevOps is here, okay? So you have a problem? No, I don't know. Community tools, a lot of them are community tools. The ones that I don't think if you can saw, but usually the ones without a gray background are open source and free to use, at least somehow. You have all the things here, okay? Don't think that you have to memorize all of these tools, okay? For example, observability and analysis, you have everything here. Monitoring, logging, tracing, claims engineering, optimization. It's all there, okay? It's all there. You just have to go to this page and check, okay, I have this problem, what are the tools that I can use to somehow fix or help me with this problem, and you will find everything here. Where is my mouse? Sorry, guys. Come here. No, where is it? Where is the presentation? Can I stop it? No. It's here. And that's it from my side. This is once again, I just want to repeat this because I think this last slide can overwhelm some of you with, but I have to implement all of these kind of things. No, you can have separated teams to work with specific tools. For example, observability and security, I think, is the most common and the most easy to understand. So security team usually are very focused on vulnerabilities and compliance and so on. Inside the observability, you always have site reliability engineers and so on. So they work on that specific area. But as a DevOps, I think is very useful, and I would say, very useful to understand your team needs, your project needs, and try to help them decide, okay, guys, you have this problem. I think this tool fits properly in our environment, and let's use it, let's test it, and I think that we can use it to achieve or to resolve that problem. Okay, guys, it's all from my side. On this QR code, you have again all the LinkedIn, Medium, XGeek, so on. You have everything there. Thank you so much. I'm available for any Q&A. Thank you.
Is there any questions? Yeah.
So nice introduction. Hello. So nice introduction. One topic that you did not mention a lot in the presentation was about security, and when you shift the culture to so that your developers also share this knowledge also about the operations and also development, we share this responsibility. And in order to reduce friction in development, you also have to reduce. You don't have to have the most secure approach to implement your infrastructure, because if you try to prevent your developers from doing anything, they won't go through this route of DevOps culture. What are your suggestions for implementing security measures in order to also allow your developers to shift to this DevOps mentality, and also keep your infrastructure safe and sound from attacks? For example, because you'll have a lot, if you work in big teams, you'll have a lot of differences in seniority in your team members, and some will be more aware of these security concerns and others won't. How do you protect against your infrastructure against these issues? I think that's my question.
I think I can I?
Yeah, actually, I think you touch on a very sensitive and a very good point. That is security. Actually, that causes a lot of friction inside teams. One thing that I didn't mention is because I think DevOps is just already such a big topic that sometimes people start to add another one. So it's DevSecOps. Okay, this is Dev and security and operations, and it tries to include security on this DevOps world, whatever that means. But I understand your question, and actually, especially in terms of development, I'm not against developers, sorry, but I understand, because sometimes it's like, let me say this, it's a pain in the ass when they have security managers to compliance, to deal, and I understand their problem. But what you have to achieve, in my opinion, my honest opinion, is first talk with them, and say, guys, I don't want to have a security vulnerability found on a penetration test, for example, or on a later stage. And actually, you can start to implement some tools, for example, on their projects, and saying, guys, this is to help you in terms of your security. I can give you one example. For example, in my current project, we are using, for example, Black Duck to evaluate licenses, security risk, and so on and so on. And one of the problems that we had a lot of time were regarding dependencies that start to have vulnerabilities and so on. And what we did on that time was, okay, guys, I understand that for you are focus on developing and delivering the best product as you can, and I know that you don't have time to focus on security breaches and so on. So what I did, for example, in that specific case, was implementing Dependabot. That is just a security tool, yeah, from GitHub. That not from GitHub, but it has an integration. That is just a security tool that will read your dependencies file. For example, if you are talking about the package.json, and you will check if there are new versions, and automatically it will create a pull request with a new version. Okay, and it will attach some tags saying if it's a minor, a major, or a patch. And I think I understand that for them this
causes a lot of friction and sometimes even some blocks on their side and their development cycle. But man, it is what it is, and I think if we can find these problems as soon as possible, and if you can set up some tools to help them, that's the way that we have to do. Because at the end, I think that what you can explain to them is like, I know that you don't have time now. I have this and that tool. I will start to search for tools that can help us on that security compliance problem. But you have to look always into it. It's not your fault if you. It's not your fault if you get any problem. But with these tools, it's like your responsibility. Okay, it's like you are putting, like Elder is always saying, is you are putting the ball on their field, right? You are putting the ball on their field, so you have everything. You have to take care of it, because if we just found these kind of problems later, it will be bad, not just for the company, because it can lose money, for your client's trust and so on. But I understand. Usually, security is a topic, a very sensitive topic that causes a lot of frictions, and sometimes I think developers doesn't understand how important it is. But for example, if you work, and also, I think it depends on the type of project, because I'm pretty sure that if you work for a bank, assurance, I think that these are the topics that they can't complain about. Okay, if you are talking about, I don't know, but a very small store, okay, the risk you can accept a higher risk, but it depends on it depends on your in your business especially, and you have to deal with that. I think that's the most honest opinion that you have to do with them, and yeah, I don't think if I reply to your question. Sorry. Yeah, actually, yes, there is an answer. As a DevOps, communication is one of the main processes, and I think that there are always people that saying, "I don't care, it's not my fault," blah 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 blah. But yeah, as a DevOps, you have to deal with teams. The best way? My way is to. My way usually is you can afraid them and say, "Oh, we have a fake penetration test in 3 months, so we have to resolve this." No, I am joking, guy. Yeah, it's always complicated, and it's always difficult to make them understand that. Sometimes it's like something so simple as like a dependency update. And I think the major part of the security breaches are just an update. It's just an update. Okay, but this will impact a lot of things on our application. Okay, I understand. Let's talk with PMs, POs, project managers, and so on, blah, blah, blah. All the management team saying, "Oh, okay, guys, this is as a critical," and then you have to set up the risk level that you accept. Okay. That's one thing, okay? And you have to talk with them and understand, okay, guys, critical, we have to resolve them, and this is compliance, company compliance, and we have deadlines to resolve these kind of issues. You have a lot of things, but at the end, they must understand that security is also part of their work, especially if you don't have a security team. Because if you have a security team, it will not be you as a DevOps or DevSecOps that will talk with them, it will be the security team.
Yeah, but, you are shifting away from
Yeah, you are just passing the ball to the other field.
No more questions? Okay, thank you. Thank you, Sarah.
Thank you.
Thank you. So hi everyone. As Rita said, I'm Fabio. I'm the community specialist here in XKicks. I was the one who spammed your mailbox with a lot of messages and contacts and heads up about this meetup. So sorry about that, but I will continue to do so. So be prepared. You join us now. You have to take this risk. So first of all, I want to thank. This is the thank you part. I want to thank all of you for being here today. It's very important for us, not only as a company, but as a community and for our city. Then I also want to thank the persons that made this possible. I want to thank our organizing team, our main sponsor, XKicks, our speakers, of course, Serra and Elder. Thank you for your time and for your amazing talks. And I also want to thank, a special thank and a big kudos to our engineering team. I don't know if you know, but they were very proactive in their invitations, in their contacts, and I think that many of you are here because of them. So I want to give them a round of applause for that. So thank you, guys. Thank you. Thank you. And I think that this is it. I want to ask you and encourage you to keep in touch with each other, build the bridges. Let's grow this community together, and keep in touch with us. And now I will give the floor to the second reason why you are here. That is the peas and the beer. I don't know if you noticed, but you can already smell it. So let's enjoy the rest of the evening. Thank you.